it is awesome to have Dave Royle back with us again. For those that didn't see it, I highly recommend watching his recording on 2 grassroots discoveries in PNG and Indonesia. But today the focus now turns to South America and exploration that was carried out in the 1990s, which turned out to be a period of prolific mineral discoveries. So Dave has dug up some amazing stuff. There's maps, photos, all sorts, and some which has never been seen before. So I hope you all enjoy it. Please use the chat. We'll open up the floor at the end, and it's just wonderful having you on again. So thank you so much, Dave.
Yeah, thanks, Jess. I really appreciate that. And also for mentioning that this is a sequel to that talk I gave last year. So some of it's kind of relevant to what I'm going to be talking about now. Okay, so you'll see the slide there. That's actually not part of the talk here, but it is in Peru near Cerro de Pasco. A really amazing trip I took, and that's an Incan trail, and there is our transport going over the Incan trail, central Peru. So let's start the talk now with creation of Newcrest Mining, which was a merger between Newmont Australia, who I'd been working for, and BHP Gold. I relocated with the family to Santiago in early '91 to establish the first company's overseas exploration office. We'd been looking mostly at Chile and Bolivia for the search for epithermal gold and kaolin type deposits. But after a couple of years, we hadn't been making any great headway, particularly in Chile. So we started looking at Peru and Argentina, and we began a few studies. And by the mid-93, there was no budget for this work. However, the interim Newcrest manager at the time, Courtney Chamberlain, who was a very good friend of mine, he found the funds and enthusiastically supported the work that we wanted to do. I think each program we put up was about a bit over $100,000 each, which we just didn't have right at that time. So in the spring of '93, we conducted 2 simultaneous grassroots helicopter supported programs that were undertaken, one in Argentina in the Deseado Massif, and the other one in the Zamora-Chinchipe region of northern Peru. As a direct outcome of that work, 2 important deposits were discovered by the Santiago-based team of Newcrest: Steve Nano, Johann Schmidt, Simon Meldrum, and Bob Cassicelli, an American. The first one was Cerro Negro, the gold-silver epithermal deposit in Patagonia. The second one was the Rio Blanco Cu-Mo Porphyry in the high country of northern Peru near the Ecuadorian border. After leaving Newcrest in mid-94, I completed a regional geological and geochem program in October of '94 in the Rio Santa Valley in central Peru, which is shown here. So there were those 2 discoveries, and then after leaving Newcrest, I completed a program in central Peru in the second half of '94. That was a precursor for the discovery of Pierina, shown on the map here. Those stories and many others have been tabled in a book called Australian Mineral Discoverers, which is shown here. So one other comment before I just go on to actually the beginning of the story here. As you probably know, the business of exploration and discovery stories differ depending on who's telling the story, and all I want to say is the following is just another version. So let's go now to the remote and sparsely vegetated plains of the Deseado Massif in southern Patagonia. Initial interest in the region for Newcrest came when I did a field visit in February of '93 to a newly discovered deposit called Cerro Vanguardia. It had been put up for tender by the government agency Formicruz, and the thing that struck me when I went there was, and you'll see these samples on the right-hand side here, was just the incredible similarity, both the geology and the textures, to what we saw at Tolokuma in PNG and the Pajingo deposit in Queensland. Unfortunately, Formicruz had split the vein system for tendering into two blocks, and they'd already given the core part to Anglo-Americans. So Newcrest thought that that wasn't something they wanted to get involved in. But what we did recognise is that we thought that a well-directed program in that district could find a significant high-grade gold deposit. The relatively flat topography and lack of suitable drainage of most of that Deseado Massif did not lend itself to conventional regional stream geochem. So another approach was needed, and we thought then maybe what we could do, and we'd noted in Chile, Bolivia and Argentina that hydrothermal alteration in both epithermal and porphyry systems could be seen on satellite images, particularly in the arid and semi-arid environment that you get there. An example of that style of alteration shown here in the Esquel property was in southern Argentina. That was in the days before sophisticated spectral sensing technologies. And so a targeting study of available Landsat satellite imagery, which was available, was undertaken by Steve Nano of the Massif, resulting in a number of spectral and topographic anomalies being identified. In the spring of '93, a 2-week-long helicopter reconnaissance was completed over the district with Steve Nano and Johann Schmidt, and the more interesting targets were visited on the ground sample. The approach taken was a variation of the airborne technique developed by AMAX in the early 80s called Jetrex. As a result of the regional reconnaissance, the main vein and Eureka outcrops were discovered at Cerro Negro with surface values of up to 5 grams per tonne. There was when we did some ground follow-up, we found other veins, places like Marianas, El Retiro, and those anomalous areas were claimed by Newcrest with a very large tenement. Silica cap, on the other hand, shown here on the summit of Cerro Negro, had already been claimed by a prospector in '92, Roberto Schupak. So Newcrest took out an option with him to claim that area. Preliminary mapping and sampling of the vein zone and silica cap were completed in the first half of '94. All the known mineralisation shown here with low sulphidation epithermal quartz adularia veins and breccias hosted in subaerial rhyolitic to dacitic tuffs. And as a result, the observations that we made were that these veins were almost identical with those at Vanguardia. So we found what we had set out to find when we initiated that program. Newcrest continued to explore the claims, completing geological mapping and sampling in '94. That work identified gold mineralisation also at the western end of the Eureka vein zone, and also a little prospect called Mariana. The impressive Eureka vein, which is shown there as that China wall, had shallow level epithermal textures, including coliform and crustiform banding and lattice bladed quartz. So in terms of the geological setting, Cerro Negro veins are situated near the western margin of the Deseado Massif. It's about a 60,000 square crustal block in southern Argentina. It's bound to the north by the Rio Deseado, or the river, and to the south by Rio Chico, to the east by the Atlantic Ocean, to the west by the Andian Cordillera. The massif is a back arc position relative to the Andean subduction zone, and late Triassic to Cretaceous extension phase linked the opening of the South Atlantic Ocean that triggered Mesozoic and Cenozoic magmatism throughout the massif. All the known gold and silver deposits in the Deseado Massif, shown as yellow dots on that slide there, they're hosted by Jurassic volcanic sequences. The region's now an important gold and silver producer, with over 3.5 million ounces of gold and over 50 million ounces of silver produced every year from 5 operating mines. In terms of just the the local geology. Cerro Negro is contained within a 500-metre thick sequence of Jurassic volcanic rocks that unconformably overlie Paleozoic basement. The distribution of the volcanic sequence and related subvolcanic intrusions is influenced by the northwest and northeast faults, which are shown on the plan. Those faults are both conduits for subvolcanic intrusions feeding the volcanism, and as the structures that define the margins of little grabens filled by the volcanic rocks. The youngest rocks you'll see on that slide are right in the middle of the plan. Gold and silver veins are shown as pink lines on the slide here. They strike northwest, west-northwest, and east-west. They're multi-stage and have been in place at a very high level and are remarkably well preserved. The next slide's a really interesting one because a series of post-mineral rhyolite domes and their ignimbrite aprons basically protect the epithermal systems as well as travertine and sinter deposits on a late Jurassic paleo surface. So this one here, this slide shows hot spring related facies at Cerro Negro, such as fossil vents and similarities to recent geothermal deposits at Yellowstone. They are interpreted to represent subaerial travertine fissure mounds and apron terraces. Really interesting thing. I've never seen that before myself. Newcrest concluded from their work that the vein zone was unlikely to reach their corporate hurdle for development and subsequently dropped the ground without drilling. So in early 95, I'd already joined MIM and investigated what was going on with the tenements in that area. And due to a combination of Newcrest dropping its option on the silica cap claim, the ground becoming available, I claimed the area for MIM in 95. And between 95 and 96, MIM completed mostly work around the vein zone and the silica cap shown here. But as well, we did some IP and things like ground magnetics. The western part of the property covering the Eureka Mariana area was still held by Newcrest, who were not actively exploring. So we did a deal, amalgamated the respected areas in December 97, explored them under a JV agreement with MIM as the operator. Later in 99, Newcrest withdrew from the project, leaving MIM as the sole owner of the property. A total of 17 RC holes were completed by MIM in that vein zone, and silica cap areas shown in the section and plan here. At the vein zone, it's about 500 metres long by about 80 metres wide. We calculated roughly we had 500,000 ounces of economic grade. The vein zones are west-northwest trending arcuate system of quartz veins, sheeted veins and breccias with very steep dips. The resource that we found there was considered not big enough for MIM, so a deal was done with a company called Oro Plata, which is a privately held company based in Sydney, who optioned the project from MIM in the year 2000. Work completed from 2000 to 2003 by Oro Plata was mostly focused around the vein zone and Eureka. It was recognised that the accumulated thickness of the quartz veins at the vein zone, shown in the section here, which is I think about 35 metres, the geometry would be favourable for open pit operations. They did further work and calculate, this is Oro Plata, and they calculated 6 million tonnes of 3.2 grams per tonne gold. In December 2003, Andian Resources entered into an agreement with MIM to acquire 51% of the property and subsequently acquired 100% interest through acquisition of Oro Plata. Andian became aware that the vein zone would never be a company maker, so they started doing mapping and sampling around the Eureka vein. That geological work with a bit of geophysics led to the discovery of blind high-grade shoots at Eureka West, shown here. and that really was the game changer for the project. The first hole went into 52 metres of 25 grams per tonne gold and 379 grams per tonne silver. Truly a really good intersection. In 2010, Andian delineated a resource of 2.5 million ounces of gold, 23 million ounces of silver in 3 vein deposits. And in 2010, a feasibility study was carried out on those 3 vein systems, Eureka, Vein Zone and Cerro Negro, and these studies showed positive economics. Continuing work by Andian discovered 3 more discoveries in the period 2009-10. That was mostly geological work, but supported by IP geophysics. And the 3 new discoveries were San Marcos, who are shown on this slide here, San Marcos, Mariana Norte, Mariana Central. Like Eureka, the discoveries were significant blind high-grade shoots. And an example, a really nice example, you'll see there, the core sample averaged 0.85 metres at 2,682 grams per tonne gold and 1,500 grams per tonne silver. It shows, importantly, Hishikari-style coliform and Gingro fine silica adularia sulfide textures. After those discoveries, the total gold resource for the project increased to 5.3 million ounces. The Marianas San Marcos vein systems, shown on the slide, contain 70% of the gold silver resources in the district. That was the ground that Newcrest had abandoned. Goldcorp bought out Andian Resources for, get this, 3.6 billion in 2010. And the first gold production at Cerro Negro commenced in 2014. That was 20 years after the initial discovery. At commencement of mining, the estimated resources had increased to 5.7 million ounces of gold and about 50 million ounces of silver. And in 2019, Newcrest acquired Cerro Negro as part of the Newmont Goldcorp transaction, and Newmont has now 3 underground veins that they're operating on, or vein systems. Annual production in 2019, which was the last record I could get, was 334,000 ounces of gold. I don't know what the cash costs are, but I suspect they're quite low. So move now from Patagonia up to northern Peru. It was another Newcrest Reconnaissance program, which was initiated almost at the same time as that one that was carried out at Patagonia in the spring of '93. The initiative was a direct result of a study undertaken by Simon Meldrum, who examined the potential of tertiary volcanic belt north of the recently discovered Yanacocha high sulfidation epithermal discovery. The map on the right shows the area selected for assessment. At least 14 small porphyry systems were known to exist in the belt. They were known to have some gold in them, so we were quite interested in those. And however, to our knowledge, no systematic exploration had actually been done in the belt. And so we were encouraged by that. And we'd also heard via the grapevine that Newmont had not considered a regional program, grassroots initiative like this, as they were focusing almost entirely on Yanacocha and the immediate area. So it was a matter of being in the right place at the right time. The approach taken by us was based on that mountainous country, which you can see in this slide, was regional drainage geochemistry. And to cover the remote area, we were advised that we should use an army helicopter, believe it or not. The reason for this protection was that the rebel Tupac Amaru revolutionary movement operated in the area in the 80s and early 90s, at the same time as the large Shining Path insurgent, the Sendero Luminoso, were operating elsewhere in Peru. We saw no evidence of that terrorist activity when we were up there, but it was interesting. The local villagers, every time we flew over, they'd all scurry off and were quite concerned about who we might be. But when they found out we were gringos, they welcomed us with open arms. The exploration approach was the same method that had been used highly successfully by Newmont in Indonesia and PNG, which was the talk I gave in December, basically resulting in the Batu Hijau and Tolokuma discoveries. We used BLEG and -80 mesh multi-element sampling with gold panning at each chosen site, plus rock float analysis. The program was designed primarily to discover epithermal systems of gold, but also gold-bearing porphyry copper systems. Most of the area was remote, mountainous country at elevations between about 2,000, 4,000 metres, something like that. Sampling was done nominally, as we normally do for these programs, one sample per 5 to 10 square Ks. There were 3 geos on board, including Simon Melvin and Bob Casticelli, shown here, and myself. A number of targets shown as red circles here were found. However, the program failed to locate any standout gold anomalies or signs of significant epithermal mineralisation. Nevertheless, the drainage program did generate a significant copper moly stream anomaly, 50 k's southeast, I think it was, of the Rio Blanco River, forming the Peru-Ecuador border. As seen on this slide here, the Peru-Ecuador border country is very mountainous and rugged with few accessible roads and really not a lot of landing sites for helicopters either. So follow-up prospecting of the anomalous drainage by Simon Meldrum in the first half of '94 that discovered interesting porphyry float that assayed up to 0.7% copper. There was subsequently some confusion as to where exactly Simon had taken his sample, as the topographic maps for the area were not accurate. This was in the time before GPS navigation. In '94, Johann Schmidt had taken over management of Newcrest's Peruvian operations, was keen to see that stream copper moly anomaly followed up, and after several attempts to do that, Henry Marsden finally stumbled on the prospect area after a 2-day trek on horseback and walking through this really tough country, not unlike the highlands of PNG. The prospect area presented as a vegetation anomaly, mostly treeless and bracken and grass cover. Have a look at that top left-hand photo, which shows that quite nicely. This was like many other virgin outcropping porphyry systems in tropical regions of the world. Henry's initial mapping broadly defined the limits of the system, which measured about 2 by 3 Ks. His rock chip sampling returned very anomalous copper moly values, but no gold or silver. And there was no evidence of prospecting or mining anywhere in the district prior to Newcrest exploration in the area. Based on the positive copper assay results, attempts were made to acquire that area. You see on the map where the star is. However, at the time, foreign companies were not allowed to own mineral title in the border region. Instead, an arrangement was made with Newcrest's Lima-based lawyer, allowing him as a Peruvian citizen to claim the area to be transferred back to Newcrest at a later date. And in '97, a decree was awarded to allow foreign companies to explore in the border region, and the title was then transferred to a subsidiary of Newcrest. Follow-up work by Newcrest indicated the presence of mineralised porphyry with strong copper rather than gold potential. And as Newcrest was principally interested in gold, it started looking to farm out the property in '95. So the real exploration work didn't really start till Newcrest signed a JV agreement with Cyprus to explore that area. The company called Minera Coropacha was formed for that purpose. As you can see here, the program was helicopter supported throughout. An extensive program of mapping and sampling was undertaken, and then 7 core holes which produced some quite interesting results. showing enrichment in the near surface. Two of the holes returned values like 130 metres of 1.1% copper and 123%, 103 metres averaging 1.47% copper. So work in 97 to 98 was designed to explore the full extent and economic potential by geological, geochemical studies, and then additional, I think we did 11, I think there were 11 holes. After the 18 holes were drilled, it had indicated that that there was quite an interesting supergene zone on an area called Henry Hill, averaging 1.2% copper over about 1.3 kilometres of strike length. That was on the top of or rather on the edge of a circular zone of about 1 kilometre in diameter of primary sulfide grading 0.54% copper and 0.03% moly. So the geology of the Rio Blanco district is dominated by the Porphyry granite batholiths, which is shown here in pink on the geological plan on the left-hand side. It's one of a series of tertiary batholiths that characterise southern Ecuador and northern Peru. The multi-phase Rio Blanco porphyry complex has a quartz porphyry core, shown as pink on the plan and section on the right, which intrudes an early feldspar porphyry complex shown in the green colour. Igneous breccias extensively developed within the porphyry complex and appears to have formed around the margin of the quartz porphyry during intrusion. The breccia constitutes an important site for higher grade copper in the deposit. So let's have a look now at some of the. This slide shows a summary of some from a really old report, but shows some interesting aspects of the mineralisation. The mineralisation is associated with intense phyllic alteration and a peripheral propylitic alteration zone, which covers about 5 square k's. The alteration has an overall triangular shape, as shown in the plans here. The phyllic alteration in yellow is centred on the Rio Blanco porphyry complex and overprints the potassic zone. It has been in turn overprinted by widespread argillic phase. Rio Blanco is geochemically zoned with anomalous moly in the centre, surrounded by copper, and all other elements like gold, silver and arsenic were only weakly anomalous or at background levels only. The deposit's has a well-developed supergene blanket with covellite and dominant mineral with supergene blanket and is overlain by a Goethe leach cap. The samples here of core from Newcrest Cypress drilling mostly show the oxide and supergene zones in the deposit. The supergene blankets developed in an area of strong relief with better accumulations of higher grade about 50 to 100 metres below the crest of the ridge on Henry's Hill. Within the secondary enriched zone, the ore is characterised by typically chalcocite and covellite occurring as disseminations and veinlets. The hypogene zone is characterised by disseminated and fracture-controlled chalcopyrite and very minor covellite and bornite. Cyprus retained interest in the project until the company ceased to exist when they were taken over by Phelps Dodge. By that stage, Newcrest had also ceased to exist as an entity in Peru, and their interest in Minera Coropracha, which is the sub-company, had been bought out by Geochemistry, which is a little Canadian junior who assumed full ownership of the project. They didn't do very much work, and basically the project remained dormant most of that period and until early 2002, when Monterrico Metals reviewed the data and concluded that a project of about 100 million tonnes of acid-soluble copper of material grading about 1% copper could be found. In April 2003, Monterrico acquired 100% interest in Geochemistry's interest, and the project was sold for $1 million US and 400,000 Monterrico shares. Soon after that field work and a relog of the Cyprus drill holes, there was a grid-based drilling program got underway. There was a period of about 12 years, or 10, 12 years of intensive exploration, which is interrupted by many shutdowns due to anti-mining community unrest. Monterrico published a total resource, finally, of about 1.2 billion tonnes of 0.57% copper and 0.03% moly, truly a world-class deposit. Monterrico was taken over by Zijin Mining Group in 2007 for a payment of $186 million. Zijin planned to develop the deposit costing about $1.4 billion. However, a loose coalition of environmentalists, Catholic priests, NGOs, local people, and probably agitated by local drug lords, ramped up an anti-mining campaign against the project, preventing further exploration and development. Some of the reasons were that the opponents said that the mine would pollute rivers, which were vital for farming in the valleys and lower down, and accused the company of ignoring their opinions. However, the genuine fears and grievances were mixed with much misinformation and political manipulation, really, which was a familiar pattern in Peru. Sadly, the project remains undeveloped 28 years after discovery, which is an example of lack of successful engagement to gain the critical social license to operate. So now moving to a brighter story. After leaving Newcrest in mid-94, and while still I was based in Santiago, I completed a regional and geological and geochemical program in October of 94 for David Royle to evaluate Arequipa Resources' large property holding in the Rio Santa Valley of central West Peru. Prior to the discovery of Pierina, the Rio Santa Valley was considered a base metal and silver province, and indeed it was regarded as a gold hole within the Peruvian Cordillera. Dave Royle's ability to look beyond the accepted norm and focus on geological controls and gut feel mainly was one of the important contributions leading to the eventual discovery of the deposit. However, Arequipa was focused on porphyry copper exploration, which was really David Royle's love, in southern Peru at a time when the Huaraz Valley was not a priority. In fact, Arequipa had done no field work on their large tenement holding, which was due to expire with little or no geological information available at that time. I managed to get hold of some basic topo maps and old air photos, and I remember Johann Schmidt very kindly provided me with a satellite image of the area, even though I had left Newcrest at that time. The Rio Santa Valley is bound to the east by the beautiful snow-capped Cordillera Blanca, with peaks rising to 6,700 metres. It's a favourite area for mountain climbing, by the way. And to the west is a very different looking range, the Cordillera Negra, a rugged, dark coloured mountain range, lower elevation of about 3,000 to 4,000 metres. The valley from Huaraz to Caraz is centred on the Yungay Graben, which runs about 80 kilometres in a north-northwest direction. Because of that ideal topography, I've decided to apply a regional drainage geochem approach, as well as examining as many of the mineral occurrences as possible. For the work, Rigoberto Soto, who was a local geo, and we completed a regional BLEG and -80 mesh geochemical survey over the entire area between Huaraz and Caraz in October of 94. We selected 55 sample sites and basically tribs of the Rio Santa. The density of sampling was the same as previous ones, one sample per 5 to 10 square k's. And at each site, in addition to the stream sediment sampling, importantly, we did gold panning as well as float analysis. Most of the field work was carried out on foot or by horses. Access to the area was restricted to narrow footpaths. Incidentally, it was very interesting when we went in there. Was after the Sendero Luminoso the Shining Path had been all through this area, but in some years prior to this, they'd abandoned the area. But when we went into little villages, we could see signs markings on walls and so forth of their presence in the area. So fortunately, they weren't there anymore. A number of geochem and alteration and structural targets were highlighted by the outstanding and best geochem results within in the entire program were just north, about 8 k's north of Huaraz. Here's shown here are some of the stream results. And the first one to show you is the BLEG result of 121 ppm BLEG, contrasting with a background in this area of 0 to about 5 ppb. The minus 80 mesh result was 203 ppb, an outstanding result, and copper gave a 124 ppm result. More importantly, in the pan, there was mustard gold, about 1 centimetre to 2 centimetre long, little trail of mustard gold that came out of a quebrada or creek called Pakchak, about 5 k's from the source at Pierina. As I'd already turned to Brisbane with the family at the end of November '94, I recommended to Rigoberto, the geologist I'd done the survey with, to investigate the headwaters of the anomalous catchment, preferably by helicopter. And the TM image, satellite image, clearly showed a colour alteration anomaly along a northwest trending ridge, which turned out to be argillic alteration surrounding the discovery site, shown on this slide nicely. Samples of silicified rubbly bleached outcrop were taken on the initial follow-up by Rigoberto and his team on the hill, which was called Cerro Ancash Punta, which was later called Payback Hill. That returned anomalous gold values in the 1 to 3 gram per tonne range, surrounded by a broad area of argillic and propylitic alteration. So all very interesting. Subsequently, work by Arequipa consisted of detailed mapping, surface rock chip and pit sampling, and driving at 2 exploration tunnels. And that was on Payback Hill, near where this photograph's shown here. The 2 adits returned gold and silver, interestingly 2 to 4 times stronger than the initial surface rock chip sampling. Just an example, one of the tunnels, the first tunnel, there was 107 metres averaging 4.8 grams per tonne gold, and the second tunnel, which was 200 metres south, averaged 44 metres of 7.8 grams per tonne gold and over 200 grams per tonne silver. Economic gold mineralisation crops out over an area measuring about 200 by 500 metres. It's hosted in massive vuggy silica and coarse crystalline alunite, altered dacitic ignimbrite. Interestingly, the discovery caused considerable excitement. I don't know whether anyone was around at the time, but it was amazing, with a lot of speculation about what this property was all about. Arequipa shares, which were just cents, ultimately ended at $30 per share. And by April of '96, drilling had commenced, as well as construction of a road access from Santo Toribio mine to the south. And after 9 holes were completed, Arequipa announced an inferred resource of 3.5 million ounces. And by mid-'96, all the major gold companies were circling and a bidding war started. Barrick won the race, paying, believe it or not, $800 million to take over Arequipa in August of '96. So in terms of just a bit of geology, Pierina deposit lies about 5 k's north of that coeval Santo Toribio silver-based metal intermediate sulfidation epithermal deposit. And up till that time, Santo Toribio really was the only significant mine in the valley. And the project lies at about 3,800 to 4,200 metres in the Cordillera Negra. The Cordillera Negra is basically made up geologically of Jurassic to Cretaceous sedimentary volcanic rocks overlaid by an Eocene to Lower Miocene andesite, dacite and rhyodacite. They are in turn cut by tertiary granodiorite, shown there on that slide as pink. A 70-kilometre belt of alteration in the Cerro Negro corresponded to a series of eruptive centres and minor silver base metal deposits. The alteration zone directly correlates with a nor-northwest trending Pliocene to Pleistocene graben filled with pumice and tuff. Pierina is a high sulfidation, acid sulfate, epithermal gold-silver deposit, and a very good one. It's been emplaced into mid-Miocene, into hyperbyssal to intrusive pumiceous tuffs and underlying older dacitic flow dome complex. The mineralisation here shown in this section, the deposit exhibits classic lithological and structurally controlled advanced argillic alteration with a core of vuggy silica successively surrounded by quartz alunite and distal argillic and propylitic alteration zone. The bulk of the resource is focused within a single shallow dipping welded rhyodacite unit dipping to the northeast as shown on the section. The deeper mineralisation structurally controlled and the mineralisation is focused within an upward flaring silicified structure that extends along the axis of the deposit. The gold's very fine, it's disseminated as micron size native gold grains associated with iron oxide, quartz and pyrite. Importantly, 95% of the ore at Pierina is oxidised or was oxidised, which is regarded as both supergene and hypergene in origin. The oxide nature of the ore proved to be ideal for cheap heap leach extraction of the gold and silver. There were some remnants of the underlying, well, there were little kernels of pyrite in enargite, cobalite, and a bit of native silver, which were found locally, demonstrating what the original primary mineralisation probably would have looked like. After the rapid purchase of Arequipa resources by Barrick in August of '96, Barrick initiated an aggressive drilling program. They put in about 35,000 metres, proving up a resource of 8 million ounces of gold, 49 million ounces of silver. Construction of the road and the leach pad started in October of 97 for a cost, I think the construction was about 260 million US. Open pit mining commenced in November of 98 and gold production started later in 98 and continued all the way through to 2016. The discovery to production was rapid. It was amazing. It only took 4 years, which is testament to the high quality of the deposit. The ore was treated by heap leach processing, about 80% recovery, which is great, to produce 821,000 ounces of gold in the year 2000 at a cash cost of only $40 per ounce. After 3 years production, the production decreased to about 500,000 ounces a year. As it turned out, the mine was one of the lowest cost gold producers in the world. The slide here, which is a really nice one, shows it's sort of looking northeast. It's a panorama of Pierina open pit heap leach operation, and it looks towards the snow-capped peaks of the Rio Blanco. So, in terms of concluding this presentation, all the 3 deposits were grassroots discoveries found in frontier regions that had not been systematically explored using modern techniques. Discovery methods that had been highly successful in Southeast Asia and PNG were applied to the South American exploration effort. Area selection was conceptual, mostly looking for epithermal gold and gold-bearing porphyry systems. Drainage geochemically using the BLEG technique and -80 mesh sampling with a regional district approach led to the discoveries of Rio Blanco and Pierina. Satellite imagery was used to define colour alteration and topographic anomalies to discover Cerro Negro. All the discoveries were exposed and found by smart follow-up prospecting. Bedrock geochem and alteration and structural mapping with a little bit of geophysics defined the drill targets. Developing a new mine from discovery does not happen overnight. You go from an amazing story of only 4 years for Pierina, while Cerro Negro took 20 years and Rio Blanco remains undeveloped 20-80 years after discovery. And finally, Cerro Negro and Pierina demonstrate the tremendous value creation through discovery. To conclude, working in South America was really one of the most enjoyable and rewarding times of my career. It was a true excitement. The Latino culture is intoxicating and very exciting, mainly due to the wonderful people, the delicious food and the awesome music. Finally, I'd like to acknowledge the help of Simon Meldrum, Johann Schmidt and Neil Stewart, who sourced information, maps, photos shown here for the presentation for me. I really thank them a lot. And on that note, I'd like to thank Jess once again for the invitation to talk and for all you listening to the story. Thank you.
That was amazing. Thank you so much.